Hi everyone. Today we are going to discuss about candidate elimination algorithm. Let's start the session. Candidate elimination algorithm is a concept of learning algorithm that finds all the hypotheses consistent with the given training examples by maintaining a specific boundary and the general boundary, together forming the version space. In candidate elimination algorithm, it uses the concept of version space. Candidate elimination algorithm considers the both positive and negative values, either yes or no. In finance algorithm, it only considers positive values. In candidate elimination algorithm, it considers both the negative and positive values. It considers the both specific and general hypotheses. Candidate elimination algorithm consists both the specific and general hypothesis. If we are getting the positive samples, or else if we are getting this negative samples, what we can do? Let us see. For if we are getting the positive samples, we have to move the hypothesis from the specific to the general hypothesis. The specific hypothesis is represented as a symbol of full file, and the general hypothesis are represented as a symbol of question mark. For the negative samples, it moves from the general to specific hypothesis. Here we can see the diagrammatic representation of the positive samples and the negative samples. Here, yes, positive if we are getting the positive samples, it moves from specific to the general hypothesis. If we are in this diagram, we can see the negative. If we are getting the negative samples, mm, it moves forward to the general to specific hypothesis. Here we have to initialize both general and specific hypothesis, S and G. S is full of full face and G is full of question marks. S is denoted as specific hypothesis and G is denoted as general hypothesis. The number of symbols taken depends on the number of attributes we are taken in the data. Let's move to the second step. For each sample, if example is positive, if the sample is positive, we have to make specific to the general hypothesis. Else, if the example is negative, you have to make general to the specific hypothesis.
So in this example, if you see, we have 6 attributes, right? 1, 2, 3, 4, 5, 6 attributes, and this is the decision value you will not consider as attribute. So apart from this, you have 1, 2, 3, 4, 5, 6 attributes. Therefore, you need to take 6 symbols. That is the reason why you are taking 6 fives and 6 question mark symbols. Okay, and in the next step, what you have to do, you have to check whether it is a positive or negative, right? So here, if you see in the first case, sunny, warm, normal, strong, warm, and same, what is the classification? Yes or no? It is S, right? S means positive. So this is positive. In this case of positive example, what do you have to do? You have to correct the specific hypothesis into the general one, but that in this case, you don't have any predefined hypothesis. This is the first example. So you have to write all the attributes as they are: sunny, warm, normal, strong, warm, same. All attributes should be returned as they are. The general hypothesis also remains. It is because that we don't have any negative values yet. Until and unless we encounter a negative value, the general hypothesis remains the same. Now, in the second step, what we have to sunny, warm, high, strong, warm, same, and the value is S. S means again positive. So for a positive example, you have to change from specific to general. Here, you already have a specific hypothesis defined, so you need to convert it to a more general form. General means including questions mark where necessary. You need to compare the already defined specific hypothesis with a new example. First, sunny and sunny it remains same. Warm and warm. You need to compare the already defined specific hypothesis with a new example. First, sunny and sunny. Let it remain the same. Warm and warm. Let it remain the same. Normal and high. Here, the value are different, right? So, in place of normal, you should replace it with a question mark. Now, let us check the remaining attributes. Strong and strong, same. Warm and warm, same. Same, same, right? So, only in place of normal do you replace it with a question mark because the values are not matching. If the values matches, you keep them the same. Since they do not match in the case of positive example, you generate by replacing the question mark. Now, G2 will remain as it is because, as I said, until and unless you encounter a negative example, the general hypothesis remains the same. Move on to the third example. Rainy, cold, high, strong, warm, change. And the value is no. No means negative. For a negative example, what do you have to do? You need to move from general to specific. In this case, you should keep the specific hypothesis as it is. Whatever you have in S2, you write the same in S3. Now, you need to modify G3. You should compare the negative examples with S3 while specializing the general hypothesis. We have six attributes. In S3, the first attribute is sunny, but there for sky, we have rainy. So, there is a change in the attribute. Whenever there is a change in an attribute, you write sunny in this position and keep all other five attributes as question mark. The second attribute in S3 is warm, but there is cold. Again, there is a change. So you write and in a second position and keep all other as question mark. Now check the next attribute high and high. Same. So no change required. Strong and strong, same. Warm and warm, same. But the last attribute is same in S3 and change in the example. So this is different. Therefore, you write same in the position and keep the remaining five attributes as question mark. That is how you are the general hypothesis for the negative example. So now we have S3 and G3. G3 remains the same because the negative example. In case of negative example, you do not modify the specific hypothesis. Just like in positive example, you need to not modify the general hypothesis. Now moving the fourth example, sunny, warm, high, strong, cool, change. And then the value is S. S means positive. So what you do, how to change now? You should change the specific hypothesis since it is a positive example. Now compare S4 with S3. If the attributes are the same, keep them as they are. If they are different, replace them with a question mark. First attributes sunny same as in S3, so it is remain sunny. Second warm, same, so it is remain warm. Third question mark remains as the question mark. Fourth, strong, same. So it is remains strong. Fifth, warm in S3, but that is cool. Since they are different, replace it with the question mark. Sixth, same in S3, but that is change. Again different, so replace it with the question mark. So this is the S4 you obtain. Now for G4, since it is a positive example, you initially keep G3 as it is. But if any hypothesis in G3 is inconsistent with a new specific hypothesis S4, you remove it. Earlier we had sunny, warm, same in G3, but since same is no longer present in S4, now for G4, since it is positive example, you initially keep G3 as it is. But if any hypothesis in G3 is inconsistent with a new specific hypothesis S4, you remove it. Earlier, we had sunny, warm, same in G3, but since same is no longer present in S4, the part is removed, the remaining hypotheses stay the same. So, S4 and G4 are final hypotheses observed from the candidate elimination algorithm. S4 is the most specific hypothesis and G4 is the most general hypothesis. Based on this, you train your machine. The algorithm considers both positive and negative examples, and at the end, you get both the most specific and the most general hypothesis.